In Module 7.4, we are looking at MATLAB as an alternative because even with the Tableau method, it might give you a little bit of organization to help you with the solution, but still you cannot really crack large problems. So let's see how MATLAB would deal with it. So the simplex method is included in MATLAB using Lindbergh function, and all needed from your side is to express the problem in a language that MATLAB would understand. And Appendix A, which we will go through quickly, has a list of all possible options you can have. So we'll use this problem again, maximize 4x1 plus 16x2 subject to these three constraints, and x's are greater or equal 0. I'm changing it to minimization. And we'll solve it twice. First time, which is in this module, we use simplex. Then we use something more advanced called dual simplex. So here's code 1. As usual, I start with close all, clear all to avoid confusion. I define the objective function, -4, -16. These are the two coefficients here. Then I add the inequality constraints, and they should be in the form A, x equal B. So what is A, what is x, what is B? 2, 3, 4, 1, 0, 1, which I hope is correct here. On the other side, I will have 16, 24, 2.5. Okay. He's asking if you have simple upper and lower bounds on my variables. In this case, I don't have. For lower bound, I put zeros. For upper bound, I use large numbers. He is now need to supply equality constraints, which are expressed in the same form. And in this case, I have no equality constraint, so I left it zeros. X0 is initial conditions. I don't have initial conditions here also. So now how we do the search options. One nice thing about MATLAB is it gives you a variety of options. Some of them may help you understand how the solution is progressing. Some of them will give you added information or very little information if you just care about the final answer. So in option, I say Optim option, which is an optimization toolbox. I say use a linear programming algorithm using simplex algorithm, sorry. And for display, I use iteration, every iteration. So my problem would be x fval. This is the final variable values, function value. Exit flag. This will help me understand how was the problem terminated in the output. And I define FAB, all these things we defined here. Then options is the last thing. Here's the output. It's a options used by simplex as such. Set is simplex display iterations. Default properties is a maximum of iterations. This is the standard, but you can change it if you want. And optimality tolerance is such a value. So I have two variables. So I said do 200 iterations. If you exceed this, stop. And of course, it's clear for a problem with 3 inequality constraint, 200 is very generous. So here is how it progressed. It gives you feasible points, skipping phase 1, objective, the infeasibility, I had 0, 1, 2. So I ended with -57, which is the same solution like before. And it gives me the same variables, same function value, and the exit flag is 1, which we can look in the appendices, in the appendix and see what it has. And this gives me summary of what happened. It has terminated the optimization. It saw no point of continuing. And I would like you to use MATLAB to solve this problem, which you have seen last module, and also this one, which also you have seen last module. Only difference is this is after class. And here is appendix, which is from MATLAB site, so nothing really different. It give you algorithm, diagnostics, display, and you could use any of these if you want additional information, especially if you have complicated problem. So you can read it at your own time, depending on what you want to do. So I'm not going through it really beyond this. Thanks a lot. And we have one part left in this module.